Thank you so much. And thank you everybody for your patience. That was a great conversations with the organizers here. And it's really great to be in Romania, even though it's right now is virtually. But I was actually in Bucharest in 2019 for visiting the IBM developer meetup group in Bucharest. Then I also went to Brasov too. So it's really have great memory of your country. So it's really great to be here again. So thank you so much again for the invitation, and to Dan and your organizing community. So thank you. Thank you so much. So let me then start, right? So I was asked about what's the topic and what is that about? So I will give a bit of a background too. So bear with me if you're already familiar with this particular topic, but I like to kind of bring to the attention about stateful microservices. How do we do that, right, in the cloud native world? So, and I'm not sure if folks, you can answer, have any questions, or if I can look at them. But the thing is, feel free to ask as many questions as you can, as even more challenging and difficult or anything. Don't feel like it's you have to worry about it. But please answer, ask any questions. So here I am. I'm actually using this particular logo in here. It is the Open Liberty that I will be primarily be focusing on. Is an open source Java library runtime that's actually based in WebSphere. As some of you also may be aware of WebSphere, the IBM app server, what used to be in the older days, not too long ago, right? When Java came out, the enterprise Java, that's WebSphere, and now we have open sourced it a couple years ago. That's Open Liberty. So that's what I'll be talking about. So who am I? So it's very quickly, that just kind of let you know in case, right, you just can pop in. So I'm using a butterfly to describe myself, because I feel like I'm like what is called like a social butterfly, right? So fly around and be socializing. However, I actually was an engineer, development engineer, and I've done a bit of testing as well, but mostly too like development, testing, and helping, kind of the pre-DevOps days to kind of do release, delivery, all those. So essentially traversing the whole kind of stack, not so much with front end or back end, but it's more like different functions in doing software development. I have kind of touched on that. And so for the past, over 25 years, so in different capacity, right, or kind of company. So there are financial companies, or like manufacturing companies, and banks, right? And also there's also like with a health kind of startup company that actually does some kind of health insurance sign up. So all those. So I feel I have a very good exposure to understanding what's going on in the world. And plus I also have product development. Now I'm at IBM product development company. But actually when I first started in kind of the 90s, right, getting into software development, I was also doing a lot of like product development. Basically, it's, at the time, right, they're software inside shrink wrap boxes, kind of like. So I've done that too. So that's me. But currently, I'm a senior developer advocate at IBM. I've been with IBM for 3 years now, and I'm in Java, open source, cloud, DevOps, enterprise distributed systems, and that's actually my interest area. I've done a lot of also reactive technology too, event-driven projects. Again, Open Liberty, Microprofile, Jakarta EE. Those are like my open source area, and that's what I'm focusing on. I'm essentially a developer relations software engineer. I do some coding now, but less time to actually do it. And I'm also the president of the Chicago Java Users Group too. So I really love tech communities, and I get involved too and interact with my users. So that's about me, and I think I spent enough time. So let me go on. So just some background, right? Stateful versus stateless. So now, in order to describe this subject, I decided to make it more fun. So as you can see, this is the cartoon Finding Nemo. So maybe some of you, especially if you have young children, you have seen this movie, Finding Nemo. So, and let me kind of describe a little bit if you haven't seen it. So as you can see, they are about fish. So it's basically the little fish, Nemo, got lost. So the dad, the bigger fish, Marlin, and was obviously, well, can you imagine if you lose your child or cannot find, right? Then you'll be all kind of nervous looking for your little baby. So, and then in the meantime, while Marlin was like swimming in the ocean looking for his son, and he ran into this bluefish, Dory. So Dory is a very forgetful fish. And so maybe now you can start to get to why I'm using this example. I just wanted to kind of compare what is stateful and what is stateless. Now, the thing is too, let's kind of take a look at this. Computing life, right, used to be simpler in the sense that we used to be dealing with stateless computing. So what is that, right? So stateless, when we talk about, within the computing terms, it's really it's a protocol that does not retain any session information. So you don't record anything between transactions. It just happens, data comes, you process it, you take care of things, you go, and you don't worry about keeping track or anything like that. So it is very easy, right? If you think about it from an architecture, design, and implementation level, it's just much simpler. If you want to scale the system, make it kind of, more components and everything, it's much easier because in today's world of cloud native, you spin up another Kubernetes, in the cluster, you spin up another worker node or create a new pod, all of these things. Then you want to scale it up, it's easy because all you need to do is just spin it up. And then likewise, if there's any problem with it, you want to recover. So maybe one component handling some data or that particular, kind of data with the date, the component is having issue, then you basically can just say, okay, I don't worry about it. Dump it in the garbage bin, essentially, and then I can spin up another one. So it's much easier, as you can see. But realistically, we live in a stateful world, right? So we cannot just say we cannot remember things. It's essentially, that's what it is. So, and stateful computing is basically just the opposite, right? That's the communication protocol that will retain all session information. So the state of the data gets recorded at every step across all transactions. But as you can see, if you are, into doing framework development, that it is much harder to do. Because why? Because architecture, design, and implementation, if you have to design a framework for that, or even just, if you're designing application too, on all level, if you want to deal with stateful data, it's always more complicated. You want to scale your system. Every time, let's say, taking back the example, right, in cloud native world using Kubernetes, your pod goes down or something, and you need to restart a new pod. You can't just start it like that. You do need to go back to some information, right? You need to read the spec, right? These are Kubernetes terminology. You need to get the spec and also see where the state, is. So then you need to restore when you spin up a new pod to replace it. You need to kind of restore the state so then, it's consistent with the rest of the pods, in your cluster, for example, right, as an example. So likewise, too, if something goes wrong, you need to recover. That involves a lot more efforts. Now, kind of like me then go back to the analogy of using Finding Nemo. I never really completed talking about that. So, if you remember, if you have seen that movie, that when Marlin, right, the daddy fish trying to go out and swim and looking for his son, then he ran into Dory, but Dory is the complete opposite. She cannot remember anything. And so she saw, let's say, right, she saw a group of jellyfish and then she got excited. Oh, they are so pretty. Let me jump on them and swim towards them and jump on them. But we all know, right, jellyfish is dangerous because they sting you, right? So Marlin, being the normal, so to speak, right, normal fish and can remember things, right? And so he got nervous and it's like, hey, wait, don't jump on it because you can get hurt and all that. So as you can see, right, and I'm just trying to say, kind of bring this up, as you can see, if we're stateless, kind of less worry, you can do things a lot faster. I mean, that's the kind of a positive side to it. However, you are also putting yourself at risk, or maybe, you can't actually process a lot of things. And think of the fact that what if let's say you forget your wife or your husband's birthday, right? Or your partner's birthday, and they will get mad, right? So that can't happen. And we live in a world that we do need to keep track of all the data, transactions, right? In an e-commerce processing scenario is absolutely important. How can we, drop any data? We need to make sure data consistency is kind of maintained, and data integrity is of the most importance, kind of like that. So, okay, so now statefulness in the cloudless states. Let's talk a bit then. I was talking more referring to cloud time today, but let's take a look right before the all of the cloud things comes out, and how is statefulness being handled, right? And it's actually still applicable today too, but let's talk about it. Let's go back to the client server days, right? In the more like the I guess a millennium or late 1990s to early 2000s, more about client server systems, right? The web came up and everything. So as you can see too, stateful database systems on the server side. So we were relying a lot to on database style transactions. So those are like, when you do database, usually too, you can let the database itself manage your transactions, so system manage kind of level, or you can also do it so then it's user kind of controlled, or sometimes they are called user transaction. So you can control that too. So doing commit, or kind of say start a transaction, and then you go do update some records, select some records, and then you kind of filter it and then update some data. And when you're done, you do a commit, right? When everything is good, you commit. And then if it isn't good, then you do a rollback, right? So then rollback will essentially kind of, that's what it is. We'll go back to where it was before. It's kind of like that. So that's how it's being done. You can control it yourself, or you can let the database do it. And then there's also, from a transaction world too, there's this concept, right, called two-phase commit. It's actually not just concept, it's a protocol. That's two-phase commit protocol. So 2PC, right? So two-phase commit is kind of interesting. They are really designed for distributed database systems kind of scenario. So let's say, right, you have a company that's highly, complex in their IT department. Maybe they merge with another company. They want to be able to design like a system, let's say is an e-commerce system, and you can have order records stored in one database, and it can be, let's say, an IBM DB2 database, and then we, kind of acquire another company, and they actually have an Oracle database. So you want to be able to have the two systems, all of the data be kind of in some ways it's like synchronized. In some ways, it's not exactly table for table, but it can be like part of a larger transactions that you're trying to do things. So you want to be able to say, within a larger systems transaction that span across multiple databases, right, in a distributed kind of scenario, you want to have some ways of maintaining data integrity and consistency across the different databases. So let's say, right, there could be more than even two databases too. You can have IBM, Oracle, Sybase. I actually used to work for Sybase, which is their systems are being used in Wall Street, right, a lot too. So anyway, so these are all databases. So now how do we kind of do that? So the two-phase commit protocol will help. And then what it is that we need a coordinator. So that's called like the 2PC coordinator. So essentially is a middleman, right? So what it does is that, say take for example, right? Taking the example of the order entry again. Let's say if I place an order and then I have to do a bunch of checking too. Maybe then there's a payment checking. Let's not go too far yet. We need to check, right, all of the credit, kind of validate the credit for the person making the purchase. And then there's also the inventory check. You do want to make sure that your inventory has the item that the customer wants to buy. Right? So that system could be, let's say, based in Sybase database, and then your payment handling part is in an Oracle database. And then in the meantime, the order is in DB2. So we want to be able to say that, okay, now I go out and do all these different things, but the coordinator then will be there as the middleman to make sure all of aspects of your system are in sync, right? It needs to make sure that, okay, let's use this example, right? It's like voting. What is this called is a voting type of scenario. It's two-phase, right? That's why it's called two-phase commit. So let's say, right, it does something, and then basically to the coordinator will first go to the DB2 and say, hey, are you done? Are you done with your work? And let's say everything's good, then the DB2 will come back and said, I'm done. I'm all good. Give a thumbs up. And then this coordinator will then move on to the next one, to the Oracle database, and said, hey, are you done? Is it good? How's it go? What's the result? So Oracle might come back and say, I'm good. My part is all done. And then you go to the next one, the Sybase, and so on and so forth. Now, of course, realistically, I don't think any one company would use 10 different databases, but just a hypothetical. But it is possible, and it is very true that there are companies out there using multiple distributed databases that are even of different kind of system too. So let's say 3. So you go to Sybase now, and then Sybase says, okay, I'm all good, and I give you the vote, yes. So at this point, the coordinator has collected all of the answers, the results from each of the databases, and then it realized it's all good. So it says, great, now let me go back. So that's the second phase. Come back, right, and say, okay, DB2, you can commit now. And then you go to like, Oracle, and same thing, commit, and then go to Sybase commit. Now, that seems to be, well, it will work. But see, that's like one drawback. As you may be able to tell, can be very slow. And also, it's got that synchronous type of nature, right, in a larger sense, because then you need to wait for everybody. And let's say I'm asking DB2 and then asking Oracle, but the Sybase one can be down. So then what would we do, right? The coordinator would have to wait for this other all of the database to be up before this coordinator can proceed with the work. So the work is pretty much kind of, I should say, not flexible, but that's just how this protocol works. You have to wait at the phase, make sure everything's good before you can move to the next phase, and then make sure everybody has committed, it's all good. Then you can kind of go back and say, okay, all good, all commit, and then we're done. So as you can see, it's slow, and also it doesn't take into account if there are problems, then you are really blocking. You're creating a situation in which the other ones are waiting for you and they cannot do anything else. But that's actually the design of this particular protocol. Now, there's the good thing about it is that that you can guarantee the data integrity using this type of protocol, but it's very slow. It's not very efficient. Now, the one thing to point out is that it is actually still in use today too, in certain kind of scenarios too. So it's not like it's completely go away, but so that's the thing, is that we have now new ways now to handle it in the cloud native world, which I'm going to talk about soon. So I realize I'm talking kind of slowly, so let me move on a little faster. And now, client-server system in our Java world too. We have enterprise Java beans, right? If you have worked with, you're familiar with Java. There's the enterprise Java spec that came out, which nowadays is called Jakarta EE. The name got changed. I forgot exactly 2 years ago, maybe 2020 or 2019. So it's changed to Jakarta EE. So. But then before that too, when Enterprise Java came out, then it has the stateful EJB, right? And within the stateful EJB, it has session stateful EJB. So in other words, the data will be kept, alive, so to speak, like during a session. Let's say a web session. So the session is on, then your data is being kept, consistently. But once the session goes away, then basically you lose the data, and it doesn't write back to the to the database. There's no persistent to it. So then that's when they come up with entity beans. So entity beans actually map to the database table of your data and all that. So there's also entity beans if you want the persistent storage side of things. So now there's also then on the web development side, then there's obviously HTTP is a stateless protocol. So how it's being handled is through HTTP session. So HTTP session will kind of maintain the data on the server side. So, and that's actually kind of enabling servlets to communicate, right? And that's what it is. Now, on the client side, then there's client also like caching of server-side responses. So that's what is called cookie, right? So cookies are very typical and still used every day, right? And it's used for cookie-based authentication. And then there's also too, because cookie-based is a bit less efficient in a sense, because then your cookie doesn't actually store the session or doesn't. What it happens is that when you have a cookie from your client, is that the cookie is first sent to the server side, and the server would then authenticate, make sure this session is valid, and then go back and tell the client and said, okay, this is good. And the client would then have to go back over the wire to the other side and say, okay, now let me carry my load of data, my payload over again. So you can see there's a bit of an extra round trip. But for the newer kind of capability is Java, or actually JSON Web Token, JWT. So token-based authentication would be more efficient, because then the payload also include the session ID too. So then in that case, once you authenticate it, you don't need to kind of go back, right? The client doesn't need to go back to the client side and fetch, the payload to it. So those are essentially kind of like the capability, the techniques you can do in the client server world to maintain state of data. Now, we're now talking about cloud native times, cloud native environments, so stateful microservices, right? So if you're familiar, right, have been working with cloud native, and you'll be wondering, well, the cloud native is all about stateless containers. So how do we maintain data? How do we do transaction and all of these things? So, and let's kind of also take a quick look first, at cloud native computing, and just to make sure we're on the same page. And so essentially too, cloud native is really an extension to cloud computing. It addresses the true needs of enterprise level distributed business application systems. And so it's very often you see that in, business enterprise type of kind of scenario, right? Get the ecosystem. So let's look at too, what are the true needs, right? So now I kind of looked up a little bit too to see how cloud native this terminology came up. It's actually in the early 2010s, Netflix came up with this term. It's actually back, I believe it was, if I remember correctly, 2012 or 13, there was a talk that actually by the Netflix engineering teams, and they came out and they did a presentation, and they basically, because they need to handle the data in huge volumes in real time, very efficient, so they already started utilizing the clouds in the very early days. So they're pretty progressive, couple companies too are, in their space too, because of the nature of the business, right? So essentially too, they leverage on the cloud and they set these goals, and the goals are, we want application systems to be highly available and very scalable and very performant. Now, if you have been also doing reactive systems too, and this cloud native shares these goals with reactive systems, which I'll have a slide to just quickly bring it up too, because reactive systems are dear to my heart. I was doing it, the past 2 years essentially, and now kind of switching more focus to cloud native and open source Java. But anyway, so I wanted to kind of go into that a little bit. So, how did that happen? Okay, that's right. I'm sorry, I kind of little ahead of time. But okay, so I wanted to bring up, right, for cloud native application, their guiding principles is called the 12-factor application. And this is actually a methodology that's drafted up by developers at Heroku. So it's a set of guidelines or best practices for portable and resilient applications that are well suited to be in the cloud environments, so in leverage on the cloud infrastructure. And one of the factors indicates that the need for self-contained services, so which are to be deployed as stateless processes. So that's the keyword, right? In cloud native, it seems like it should be dictated by cloudless processes. And why? Because, if you think about it, cloud native, right? You get charged, because we're especially, let's say you are in most applications, let's say you are essentially renting a space in a public data center. Well, they're called cloud providers, right? So you pay, every minute, any kind of resource usages, storage or data messages sent and back and forth and all that, you get charged, by not just by the time, but how much storage and everything. So which means that in a cloud native operating environment, you want to be as lean as possible. You don't want to waste any resources. Everything you do it has to be done, and you can't be like wasting resources, because otherwise you'll be charged a higher price. So anyway, so microservices architecture too, so far, I think it's just a de facto standard, right? It's the one that kind of can satisfy this type of requirement. That's why we're hearing about microservices everywhere. That's the approach to use, in a cloud native environment. It's not just in Java, it can be done in other languages like JavaScript or Node.js has it and everything too. But, and my specific example is more with Java. And also, too, the nice thing about this is that it does not enforce you what tools to use the libraries, right? And it just gives set this stage, for some solid concepts that the applications must follow. So let's take a quick look too. And I think I'm like blocking a little bit. So let me kind of adjust myself a little so then I won't be blocking as much. And okay. And I hope you can see me okay. Yeah, okay, that's better. And so Okay, so if we take a look into the 12-factor application, right, it covers everything. It's basically go from code base, right? Your systems have code base. In the runtime, all these things you need dependencies, right? Even development time too, you do have to specify your dependencies, but they can be slightly different, right, during the runtime and the design time. So, but dependencies, right? Code base dependencies, configuration, right? So all of these. You want to store the configurations in the environment. So then you don't kind of tightly couple your configuration with your code base like that. So it makes it a lot easier to kind of deploy in different environments. And then there are backing services too, right? So you have to treat backing services as attached resources too. And you don't want them to be, again, everything has to be decentralized and loosely coupled is the idea. And build, release, run. So that's when DevOps is extremely essential to cloud native as well. DevOps is really a set of principles. It's not kind of something too concrete, but yet it gives that guidelines to, what cloud native should be. You want to be able to, kind of take all the changes and start building, and also then doing the deployment, everything very fast, so very much automated. And processes, right? And I already brought this up. The processes needs to be stateless processes, because again, it's the highly performant efficiency side of things. And then port binding, all of the internet communication, all the port too. You need to also have to export these services via port binding, right? You forward the port and all these things. And so again, the decentralized kind of concept, concurrency. You want to scale out via the process model too. So that's very important too. And now too, with cloud native, a lot of time, well, we're then talking about containers, and you leveraging on the cloud technology, which is very often these days are Kubernetes or any kind of container orchestration that helps you with dealing with also concurrency too. In addition to your application itself, you can also leverage on the infrastructure to do it. Disposability, right? So disposable, meaning, what you want systems to be able to start up fast and also have graceful shutdown. Everything, is really fast, kind of that's the kind of characteristics of cloud native. And dev prod parodies. You want to keep all of the environments as separate as possible. So then it's easier for managing it too. And then logs too, like the other helping, like with logging, with observability, health and metrics, all of these things, and logs in particular to be treated as event streams and admin processes. So that's kind of involve all of the metrics, health, all of these. How do you manage and administer your server and all that? Well, the thing is, if they say serverless, that doesn't mean there's no server. There's still servers, but they run on the infrastructure. So then your application doesn't have to worry as much. So that's a quick look at the 12-factor. So now then, question is, how do we preserve state, right, across session, transaction, and network boundaries, right? If cloud native is meant to be for stateless. Let's revisit a little bit. First, look at techniques and mechanisms. We can rely on caching, right? If you have data that travels, you can have different mechanism of caching, and that's actually not new, right? It's even in the pre-cloud days, we have caching mechanisms. So, for example, in real life, we're using Couchbase or CouchDB, or using MongoDB, Redis, right? These are all the caching. And in Java too, we have JCache, that specification. So Hazelcast, for example. So I have an example to also point you to if you're interested more into the implementation side of things. So we have this Hazelcast helping us to do the HTTP, the session kind of data, kind of help you to do that quite easily, in fact, using open liberty. So, and then there's also database style transactions, so I won't go into detail. We already talked about it. Cookies, right? And the sessions, right? The sessions that are helping to maintain the data between kind of different requests even, for example. And then tokens too, very often they are used for authentication purpose, right? So now then, let's kind of move on a bit to the cloud native infrastructure side of things. So I just only highlighting Kubernetes because it is everywhere. There's no denying. And there are also other containers orchestrator, for example, like Mesos and other ones too. But I won't go into details with those because Kubernetes is just dominating right now. But I also want to point out too, of course, there's Red Hat, there's OpenShift too. OpenShift is essentially Kubernetes, but we add value to it. So that I won't go into details today, but if you're interested too, I'll give you a kind of information you can kind of follow IBM to get more information for that. And so for infrastructure side, right, Kubernetes, it has what is called leader election. So in any kind of distributed systems, right, who is there to make decisions? You get all these pods and everything. So what Kubernetes has is that if you're familiar, right, there's the etcd, the daemon, right, it's called etcd, etcd. So that one is actually, it has to kind of select a leader to be the one to be the primary, for example. So now that's built in, but I wanted to still point this out too. So the leader itself, well, how does it have to do with statefulness, right? So and that's the whole thing, is that you still want to have kind of, so to speak, in a pod or in kind of cluster environment, you still want to kind of point out that certain components are the leader in there. So you go to it sort of like the primary, secondary kind of thing. So you have a leader election, but it's all built in. So that's not something that you need to worry so much, except I think you can also, of course, then say pick Zookeeper, for example, to help you out too. But most of the time too, you don't necessarily have to do that extra. I think unless you want to customize something about it. But otherwise, etcd already has the leader election algorithms built in. And then Kubernetes also has this concept, right, of stateful sets too. So stateful sets are designed in particular to maintain state of data, in their different, components within their cluster and like between clusters and all of these things. So that's stateful sets, and I have an example for that as well. And I realize I probably shouldn't be like, talking too long because I still have a couple more slides, but I have kind of an example that I can share with you towards the end, and you can take a look more into it. And then there's also persistent volume too. So persistent volume too, it's in Kubernetes. They actually work with the actual storage, that's a physical storage too. So you can manage those, and very often too, if you work with stateful sets, you can actually also kind of assign, kind of manage your different persistent volume. It deals with not just a physical volume, but it helps with the logical grouping and things like that. So, but that's just in a nutshell what they do. And then also in Kubernetes, it has a concept called stickiness, right? So it's called sticky session. These are relying on the cookie. It's also called session affinity. So basically too, if you have requests coming in, Kubernetes, and you don't want, right? So let's say you already have the client established the context. You don't want to lose that context, right? Next time the client goes back and does something and comes back to your particular cluster to request, you want to still have some way of keeping that session. So that's what is called affinity. You want to have the client be able to go back to the same component or the node, right? So to speak, a Kubernetes term, in the same node to continue your processing, because the benefits is that then you save time on having had to go to another, even though theoretically, yes, you can go to anyone because they get replicated the same. But the thing is, the client's already, requests already talking to this particular node. So you want the client to come back to the same node as long as they are still in the same session. So that's what kind of the stickiness is about. You want that to go back to the same one. So you don't need to have, you want to avoid unnecessary initialization kind of thing to go in. So that's kind of high level wise, and that's what it is, this cookie affinity. So much like, I think it's like cookies too are being done, right? But on a smaller scale, cookies are done between like, browsers and your web browser and also your server side. But in this case, it's a Kubernetes kind of cluster wide thing, and it kind of maintain this stickiness for the client to go back to the same node to do things, right? So that's what it is. So in a nutshell. So this is kind of actually the bulk of the thing. If we get into programming design, then this one, then it's kind of apart from the Kubernetes side. And we want to look into programming design pattern. So here it is. I wanted to point out for doing stateful microservices, the thing is too, is that you are still doing things in a, individually is still stateless, right? You deploy the microservices, they are stateless. But in terms of, your whole ecosystem, you're made up of many small microservices, and you want to have a way of, making sure the transactions stay consistent like that. So we leverage on the Saga programming design pattern. This helps to span transactions across multiple services too. So, and interestingly, with the Saga pattern is that there's no concept of rollback. So unlike database style of transaction, and what it has is called like a forward strategy. So what it's doing is that it has what is called a compensation model. So it's basically saying that, okay, I keep doing something. And of course, Saga pattern, to which I actually didn't lay out in here, but it's actually makes use of event sourcing a lot too. So you're basically keeping track of your logging of your events in a logging. You log all of the events that are happening like that. So if something goes wrong, instead of kind of rollback going back, you actually kind of say that you are at this point when you actually think of it like a transaction still. So what it does is that it will go, it keeps going, but then what it will do is that it compensate, right? Whatever was done that needs to be kind of rollback in a sense, right? Concept wise is rollback, but the actual thing is it keeps going, and it basically restore. In some ways, it's got the effect of restoring the state of where it is before you start this particular transaction is what it is. It's a forward strategy, so very different than rollback in that sense. And it's also, the thing is that you can also have two kinds of sagas. One is called choreography, and choreography is a very event-driven type of way of doing things, and that's one of the ways to do it, to do your saga. So then you don't rely on a broker or middleman to help you, much like a two-phase commit type of coordinator. So choreography is, think of it more like a self-directed type of way. It leverages on events, and everything is triggering. So then you need, it relies too on the publish, kind of a publish subscribe type of way of doing things. You want to subscribe, right, to some events. So some events happen, and then automatically too, then the subscriber, the component, will then get the event notification, and then will go and does its own thing, kind of like that. So pretty much a self-directed type of protocol kind of way of doing things. And then there's also orchestration. So orchestration are really relying on a central kind of, think of it, a component that would be coordinating things, and that's Saga. Now, I want to bring up too, there's this long-running action. It's a Saga, leverages on Saga interaction pattern, and it makes use of a compensator model. And this one is, I have an example library implementation. It's called LRA, and it's from Microprofile LRA 2, just recently released 1.0. So team has made a big progress, and IBM is a big participant in this project. Microprofile is an Eclipse Foundation microservices kind of enabling library, right? So we have the LRA right now to support the Saga interaction pattern. So, and I will quickly show you a design too, but let's talk a bit about reactive, because again, that's dear to my heart. And I talk about, right, Netflix pointed out that basically we need applications to be performant, right? Performant is really responsiveness in reactive, based on the reactive manifesto. And essentially, you don't want to, have any downgrade in performance, and that's what it is. And so there's also elasticity. It's really like the availability, right? The what is it that we said? Netflix says highly available and highly available. So essentially, that's what it is. Elastic. If you have more requests coming in, you want to have spin up more nodes, pods, worker nodes to help process your requests. Otherwise, then you want to spin down what you don't need. Otherwise, you'll be charged. And so it's elasticity. And then there's also resiliency, which deals with recoverability. If something goes down, you immediately have somebody comes in, right? A worker node is down. You want to spin up another one. So it's very highly responsive, kind of like that. So I just wanted to bring up too the reactive way of doing things, and also its message-driven nature too really fits very well, in the helping out with stateful microservices in the Saga event-driven kind of scenario. Not just with Saga, but any kind of event-driven scenario. You can pair it up with like reactive way of doing things with event-driven quite well, and kind of use this way. And in fact, I didn't go into a bit more detail, but in in Java too, then we're talking about threads too. So threads too, in a reactive way of doing things, is more efficient because then you are not dealing with the threads on the kernel level, but you are actually having threads in the user space. So we kind of offload all the burden onto the kernel main thread, right? So that's what it is. So that's just in a nutshell in 1 minute. So now I get into code example, although I feel that maybe I'm kind of time, so I'm already over time a little bit, but I will be very happy to discuss more. But in the meantime, just wanted to point out to you too, Open Liberty, from IBM, it's has a lot of capability. It is a runtime, and it leverages on the OpenJ9 Java virtual machine. And IBM too recently also has the IBM runtime called Samaru runtime, and these are like based on open source, open adopt OpenJDK. Is kind of a long mouthful thing, but adopt OpenJDK is already prepackaged with the OpenJ9 JVM, which actually everybody knows is very efficient. The OpenJ9 is IBM's kind of like how can I say, a clean house implementation that's not based on previous implementation of JVM. It's highly efficient, it's proven. WebSphere is leverages on it for years, right? The J9 originally donated to the Eclipse Foundation. So anyway, just some background information. So Open Liberty is very efficient. Think of it like Tomcat, what you used to do. Use Open Liberty. You can have Spring Boot too, that is actually launch it inside the Open Liberty runtime as well. So anyway, so I have this particular link that you can visit to get some hands-on example if you're interested to look into it. OpenLiberty.io guides, and there are a bunch of example too. So let me kind of quickly go in here. Oh, this is my example actually of the Saga. But maybe I'll just spend 1 minute on it too. But let me kind of go into here first. Open Liberty. So if you go to, I have the links in my slide deck, so I'll share the slide deck. So no need to worry about copying it right now. OpenLiberty.io. So if you go into here, go into the guides, and this is just what I like to share. Look at how nice this is. It's nicely organized. The team is still working on a lot of kind of examples too. You can see there are different topics, right? And then if you're interested, from just developing RESTful services, reactive services, testing, building, deploying to Kubernetes, we have examples for that. So please visit that. So, all right. So let me kind of go back to my slide in here, and these. Again, I leave this for you, for your perusal and for your trying out, if you like. And also, too, about the stateful Open Liberty application in Kubernetes. We also have a kind of a simple case, and I kind of work with our offering product manager, too. He put this together. So I basically have cloned this, and you can also take a look into this example utilizing Nginx, also used for the ingress, too. So stateful kube demo. And then these are some of the resources and links too. But actually, as I mentioned, as I was talking, I actually didn't get into Saga pattern a little bit. Yeah, if that's okay, if I spend 1 minute. So about Saga, right? This is an example of a choreography event-driven Saga. So just wanted to point out, when you look into stateful microservices, how can we actually do it? And this is an example of an order entry. Let's say a shopping cart. So we can actually leverage on Kafka, quickly subscribe to the events that happen that carries with the order from, let's say, an e-commerce website. So then order is received. Then I basically will then, using choreography, we have event-driven way of doing things. Then we first kind of have the inventory. Essentially, too, I have an inventory component that's actually a microservice, right? And if we talk about a bit more concrete, is the microservice that subscribe to the order microservice. So once there's an event that comes that says order created, then I immediately will kick off the inventory component to go for a check. So this goes out and check and make sure my warehouse still has the items that the customer wants. So that while it's busy doing, at the same time too, the credit check also subscribes to the order created event. It can also go out, the credit check is to check and make sure this customer has the funding that he or she needs, to purchase this product. So while these two are going, then once, the order is then waiting for it. So once they are done, then I'll get an inventory check, order inventory checked. Means it's been checked, it's validated. It validated, it goes back to tell the order. So the order can update the status itself. And then likewise, credit checked. If it's all good, then it goes back to the order and tells the order. But also in the meantime too, because they also have an event called checked, then it kicks off the payment processor to go ahead and does the payment part now. So now payment is complicated. It goes out to, normally, right, credit card, you go to a payment provider, which very often is a third party. It does all the necessary security check, account check and all these, and then process the payment. Now, once that is done, and so likewise too, if the payment get processed, then it sends back to the order and tells it, okay, this is paid now. So you update the order status. And then if it's all paid too, you also then tells the shipping processor to go get ready and ship the product and all these. So now, this is just a very simple case scenario, but it illustrates where and how you can use the Saga pattern. So, okay, so with that, then let me go back to my slides and giving you the resources and link. And thank you for your patience with me. So these are like all of the, if you want to get more into the concrete, and I have examples in here, the things that I've talked about, Saga design pattern, microprofile LRA, and some blog article that talks about it, and also the links to Open Liberty, microprofile, Jakarta EE2. And then some more resources from IBM for cloud native, cloud DevOps, all of these things. Please visit developer.ibm.com. And all of these others are for your cloud information, DevOps, cloud native. And if you want to program with Java and with on IBM Cloud, we have some a very nice kind of video tutorial too with the example too. So please visit that as you have time for it. And then these are links to Cloud Native Computing Foundation and the 12-Factor app. And also, I'd like to invite you, if you are interested too, I'm also doing a weekly live stream on Twitch too. I have different topics, but usually they are Java and Cloud Native, and not just the coding thing. Sometimes I talk about philosophy too, like programmers and how do you become an architect from developers, things like that. So just a really nice community, about an hour and a half or so every Wednesday. So at 1:30 US Central Time. So. And also get hands-on experience with a public cloud. We have cloud, kind of some free tier usage. So please visit that. There's also, we're giving out some free credit too. So please visit that. And then please join our Expert TV and meetups too. And these are IBM Expert TV. And we also have IBM Developer at meetup.com. And also like to suggest you to also come to my Java users group if you're interested. We have many different topics. And there's Java 17 coming up. So we have a speaker from Poland who will be speaking next week too. So if you're interested, please visit us there. And thank you very much with that. I want to thank you. I think you've been patient with me. I kind of go overboard again, like my usual self. I love to talk about things, but thank you. I appreciate. And please join me on Discord to continue with any discussion, and just to ping me anytime if you like, questions or something too. I learn from audience too. You ask some tough questions, and that's great. So I welcome that, and also my other links. So please follow me on Twitter, and thank you very much. And please give me feedback too. Thanks. So, thank you.
Mary, thank you so much. It's been a very, very useful walkthrough.
Yeah.
Absolutely.
We definitely learned a lot of.
Thank you.
Now we cannot see you right now.
Oh, yes, that's right.
You have to minimize the.
Sure. Let me kind of minimize myself. Let me see. Let me do that. I think I will be. I'll be like
right?
Yeah.
Absolutely.
Okay.
Much better. So thanks again. Since we don't have too much time left, we've got only 2 questions for now, and probably more in in the next sections, because we're looking forward to having you back at Code Camp.
Oh, great. Thank you. I would love to. I want to be able to come and visit Romania too. That's my wish. So for next time.
Yeah. We're also, we're waiting for that moment when stuff in person will be, the usual and the normal.
Thank you.
Yeah, we enjoy the new normal, but not that much. I don't know, speaking for myself at least. Okay, so the questions.
Sure.
First one would be stateful versus stateless. In terms of use cases, when would you choose one or the other? And the second question, because it's like completes the first one, it's when stateful is a no-no.
Okay, that's actually really, really good question. I think it's a no-no is, I think Actually, the thing is, if you notice, is that the cloud native world, we are still doing everything in a stateless way. You are still deploying containers, everything's stateless, but you are relying on external components to help you with maintaining state, right? So in some ways, it's kind of a bit of a kind of subtle thing, right? You're doing all the stateful stuff outside. So I think the thing is that because doing things stateful, especially in the cloud native world, will cost you money. So you have to kind of think about it too. Like it depends on the situation. I cannot think of exactly what the situation might be, but if you notice that at times in which you don't need to worry about the history of data, right, in between sessions or maintaining that, then you don't want to do stateful, because anytime you do things in a stateful manner, you have to keep track of it. It takes more time, more, even though you say, okay, I do it in the background, but it still takes up kind of resources too. So, and it also depends too, if you are running resources on a public computer, it uses up a lot of resources. So sometimes I feel it may not be a generic answer, but I think the answer would be, it depends on your particular application scenario. So you have to understand it well and see how it is being used. And is it going to cost you money if you kind of actually do things in a stateful way? So yeah, so it's kind of strange to think of, okay, it involves money now in the cloud native kind of world. So yeah, so that's the scenario. So yeah.
All those are definitely things to consider. I mean, yeah, in most of our engineering life, the answer is it depends, of course. I mean,
yeah, that's right.
You need to carefully analyze everything and think of what do you care of more? Is it the money? Is it the, I don't know, development effort? Is it so yeah, it's always like a trade-off.
That's right. Yeah, exactly. So yeah. I'd say, sometimes if you're just going to be doing something, in a Java world, we're saying you do a static component, right? A static class to do some things that you don't need to maintain state. More functional style is a lot faster. Maybe just like queries, some information that you just need that, and then you don't need to maintain the session, then you can definitely not worry about stateful in that case. So kind of utility, I think of utility function, then you can do stateless kind of thing. So
absolutely.
Yeah.
And that's some feedback coming directly from the audience.
Thank you,
Mary.
Sergio.
Great presentation.
Thank you, Sergio.
So